Good evening, everybody. Welcome to Chem 170 with your host, me, Dr. White. In a couple of days, it'll be the 4th of July. So can everybody see this? I got my 4th of July t-shirt on. All right, let me remind you. Excuse me. Tomorrow, Wednesday the 3rd, at 8 a.m. or earlier, I'll send out the password for the password protected PDF file, which is test number 2. You'll have, because normally I would have it the next day, 8 p.m., but that's the 4th of July, which I will not ruin your 4th of July, and I can't. So what I've done is, which is another reason why I can have this today instead of yesterday, the review on Tuesday, you will have until Friday, this Friday, the 5th of July, 8 p.m., to finish test 2 and upload your answer to the assignment area D2L. It should take you about 45 minutes, 50 minutes if you studied, maybe 40 if we were face-to-face, but you're at home. Take as much time as you need, but make sure you make the deadline. As I mentioned when I posted this, and I'll mention again, test 2 has 9 pages, 10 problems. Some of the problems are multiple part. I have never and will never put a multiple choice in a Chem 170 exam or the final. It will cover alcohols, which I'll go through tonight in a review, thiols, ethers, ethylene oxide, and my favorite, aldehydes and ketones. If you haven't figured out by the video by now, Dr. White loves aldehydes and ketones. They've been good to me and I've been good to them. My first US patent dealt with aldehydes. My last US patent dealt with ketones. All right, back to school. All right, the point breakdown for test 2, general knowledge, 11 points, nomenclature, 34, reaction, 60. Nomenclature, our problems, give the IUPAC name for the following or draw the structure from the name. And reactions, all but about 3 or 4 give the product or organic product or products. But I think 3 or 4, I forgot the exact count, will be what I call synthesis problems, give the starting material or reactants. And that's test number 2. So what I like to do now is do a review for test number 2. Now, the file you see is in D2L, cleverly named Test 2 Review, and that's in the lecture section of D2L. You scroll to the bottom and you still don't see it. There's a button that says More. You probably have to click on that. All right, let's get going. Let's talk about alcohols. And what is an alcohol? An alcohol, R group with the hydroxyl group on it, OH, alcohol. How do you name it? You find the longest chain or ring that has the hydroxy group on a carbon, and you name that as an alkane or cycloalkane. You drop the E at the name of the alkane and add OL. And if it's acyclic, you need a number. And that carbon is always going to be the highest priority, meaning it's the lowest number of the chain. Remember, you always start at one end or the other, 1, but the alcohol in this class will always have priority. Now, if you're in a ring, you don't need a number because the carbon with the hydroxyl group will always be 1, and everybody knows that, so you don't need a number. All right, 1 alcohol, when you have a benzene ring with a hydroxyl group on it, we call that phenol. Some people call it phenol. What is it? Phenol. No, it's phenol. I had huge arguments. So I worked at a company where we used about, 1 million pounds a week of phenol in our chemistry at our plants. All right, I asked you to learn common names for some alcohols. And how do you name an alcohol using the common names? Name the R group the hydroxyl group is on as an alkyl group, and then add the word alcohol. And remember, rubbing alcohol is 70 to 90%. You can get a 70% or a 90% isopropyl alcohol, otherwise known as 2-propanol, and water. Oh, don't forget, another famous alcohol is ethanol. And that's the molecule that's found in gasoline, but really, it's a molecule if you consume too much, you get inebriated, which I'm not asking you to ever do. But, the good stuff like vodka or Canadian Club. Ethanol. All right, how do you make an alcohol? This is the only reaction of the 4 tests that will be on 2 different tests. Take a double bond, react it with acid and water. Remember, water is HOH. You break the pi bond, 1 carbon gets H, the other gets the hydroxyl group OH, and it follows Markov-Nikod's rule. The carbon with the most hydrogens gets the hydrogen, the other carbon double bond gets the hydroxyl group. And let me just check. Yes, I am recording this. Sometimes I forget to turn it on, but I didn't today. All right, let's talk about reactions of alcohol. Probably one of the more challenging you'll have this semester is dehydration of an alcohol. And dehydration of an alcohol is you have an alcohol carbon with a hydroxyl group, adjacent carbon, that means right next door, connect to it, with a hydrogen. You react it with sulfuric acid, H2SO4, and the little triangle is like the little top of a flame of a Bunsen burner, meaning you got to heat it real good. And you lose the hydrogen and hydroxyl group, and between those 2 carbons, you form a double bond. Now, this follows Zaseth's rule. You get the double bond, listen carefully, that has the most carbon atoms directly bonded to the carbons of the double bond that's formed. And let me show you an example. I won't do all the general reaction, but this one and a few others that students have difficulty with, I will. Don't tell anybody I'm being nice. Shh. And remember, I will be posting a video of tonight's review later tonight. And the question is, what's the product, organic product or products that are following? And I'll do it. And we look, 3 tips for test number 2 and the rest of the tips. Test. Oh, I better reboot. All right, for the rest of the test. All right, number 1, remember, there's always 4 bonds to carbon. I can get that finger fixed one of these decades. 4 bonds to carbon. So when you draw a new structure, make sure all your carbons have 4 bonds to it, because if it doesn't, it's going to be wrong. Number 2, do you break carbon-carbon single bonds? No, you don't. So remember that, 4 bonds to carbon, and do you break carbon-carbon single bonds? No. So if we go back to this reaction, the last thing, when you're looking at a molecule, look for what's different. What's not carbon, what's not hydrogen, what's not a carbon-carbon single bond should get your attention like this. I have to throw that in. All right, oxygen with a hydrogen and a carbon, that's an alcohol. We're reacting with sulfuric acid and heat. Sulfuric acid is H2SO4, and this is a dehydration. What do you need for a dehydration? Dehydration means you lose water, a carbon with a hydroxyl group, an adjacent carbon with a hydrogen. Sulfuric acid and heat. Sometimes I'll put it at high temperature like this. Sometimes I won't. Matters how lazy I am. Remember, organic chemists are lazy. So the two carbons, one with the hydroxyl group and adjacent with a hydrogen, will be the two carbons in the new double bond. And it follows Zaseth's rule. You get the product that has the most carbon atoms directly bonded to the carbons of the double bond. So if we look up here, we have two carbons adjacent, A and B. If you lose a hydrogen from A, and the hydroxyl group, do you break carbon-carbon single bonds? No. So I have 4 across and my methyl. I'll have these two carbons, which are these two. I'll form the double bond. And I know there's 4 bonds to carbon, so I can put in the hydrogens. And hopefully you can. By the way, I didn't wear it today because it's the 4th of July, but a number of years ago, students at one class gave me a t-shirt at the end of the semester saying on the front, 4 bonds to carbon and a back of methane. I still have it. It's real cute. All right. If you lose a hydrogen from B in the hydroxyl group, you'll form this compound. Again, you don't break the carbon-carbon single bonds. Here's my hydroxyl group carbon. Here's the B. So I'm going to form a double bond between there. Now I'll put in the hydrogens, because I know there's 4 bonds to carbon. And the question is, what's the product you get? And now you have to follow Zaseth's rule. The molecule with the most carbons is directly bonded to the double bond carbons is the molecule you get. This one only has 1. You don't count the methyls. Why? They're not directly bonded to the carbons of the double bond. These two. We look at B. Here's our carbons of the double bond. How many carbon atoms are directly bonded to the carbons of the double bond? 1, 2, 3. Isn't the math hard in my class? And that's 3. And now you have to do the really tough math, which is the larger number, 1 or 3. And time's up. Hopefully you pick 3. And by Zaseth's rule, for my class, this is the product you get. And that's how you do it. Well, I feel I should have somehow moved the webcam outside like the rest of you. Nah, I like air conditioning. All right, let's go back to the review. Now, these are all reactions you should know, and hopefully you've done on the practice problems. All right, next reaction. If you take an alcohol and react it with HX, remember, X is a halogen for this reaction, chlorine, bromine, or iodine. And what happens is you replace the hydroxyl group with the halogen on the carbon that has the hydroxyl group. Again, I'll say that slowly. You replace the hydroxyl group with the halogen X on the carbon that has the halogen. If you put it on a different one, I'll mark it wrong because it is. All right, next, another way of putting a certain halogen on a carbon is with thionyl chloride, SOCl2. By the way, all these reactions, this chapter I've done for research when I was doing my PhD work. If you take an alcohol, react it with thionyl chloride, SOCl2, you replace the hydroxyl group with a chlorine on the carbon with the hydroxyl group. So if this were on a carbon number 3, the chlorine would be on carbon number 3. All right, next I talked about alcohols, primary, secondary, and tertiary, and I will never ask on a test what's in a final, what's a primary, secondary, or tertiary alcohol, but I use those terms in class, and hopefully you learned what they are. If you take a primary alcohol and O in brackets means oxidized. Now, there are different oxidizing reagents. Instead of making you memorizing them, if you were chem majors, I would, but you're not. So I use the abbreviation O in brackets for potassium permanganate, sodium dichloride perchloride, potassium perchloride, and sodium dichromate and potassium dichromate are 3 I can think of right quickly. But anyways, you lose a hydrogen on the hydroxyl group and a hydrogen from the carbon with the hydroxyl group, and you form a carbon-oxygen double bond, which you later learned, or you learned, is an aldehyde. If you take a secondary ketone and oxidize it, O in brackets means oxidized, and you lose the hydrogen here, hydrogen there, you form a carbon-oxygen double bond, and you form a ketone. Dr. White loves aldehydes and ketones. All right, next I talked about thiols. Thiol is the oxygen equivalent or the sulfur equivalent of an alcohol. You replace the oxygen ROH with sulfur SRSH. Now, the 2 things you should know about thiols are they stink. When I say stink, I mean stink. The major organic molecule or major components in a skunk odor are thiols, the remainder water. Now, the other thing you should know, methane has no odor. You can smell natural gas because a stinky thiol is put in there. And that one is T-butylthiol. I've been good, and I think I mentioned on the video, the old IUPAC name for this was mercaptan. And I think circa about 1990, they changed it to thiol. All right, but remember, thiols are added to natural gas so you can smell a leak. And I told you about that horrendous tragedy in Texas that killed all the school children and teachers and injured a lot others badly. All right, next we talked about ethers. Ether is R group, oxygen, then another R group can be the same or different, which is why I use R prime. Now, I only asked you to learn the common names for ether, and that's name each R group as an alkyl group and add the word ether. Now, the main way to make an ether is the Williamson ether synthesis named after Dr. Williamson. And here you take RO minus Na plus is called an alkoxide and react it with an alkyl halide, an R group with a halogen. The halogen X can be chlorine, bromine, or iodine. And what happens, did I tell you organic chemists are very violent? We are, because we say this attacks the carbon with the halogen, kicks it out, and the O oxygen from OR minus bonds to the carbon in R prime with the halogen, and it kicks it out. And you get sodium halide as a side inorganic product. And let me just illustrate that. Or better yet, I've been having all the fun so far tonight. I'm going to share the fun. And the question would be, what's the organic product or products for the following reaction. Your turn. And for those of you who are here tonight, when you're done, give me a thumbs up. Oh, looks like everybody's done, so I better get to work. So what do? You look for something different. What's not carbon? What's not hydrogen? Should get your attention like that. Ooh, an oxygen with a minus charge, the sodium cation, carbons, and alkoxide. Carbon, carbon. Ooh, carbon, carbon, chlorine on a carbon. That's an alkyl halide. Remember, X can be chlorine, which it is in our case, could be bromine or iodine. And this is a Williamson ether synthesis, and you get an ether. Remember, the carbon here with the halogen is the carbon bonded to the oxygen. You break carbon-carbon single bonds? No. So I have, this is my R group. This is my R prime. So that R prime, 3 carbons. Which carbon has the halogen? The center one. And that's going to be attached to this oxygen. What's on this oxygen? Our R group, which is a methyl. I know there are 4 bonds to carbon. And it's important it goes on that carbon. You put it on the N carbon of that R group, R prime, I would have marked it wrong because it doesn't go there. The oxygen goes to the carbon, bonds to the carbon with the halogen. And give me a thumbs up when you've copied everything down. Okay, thank you. Isn't it nice? I just don't rush ahead and leave you stranded. Oh, hold on, I haven't finished. That's not fair. All right, next I talked about epoxides, and I just skipped to one, ethylene oxide. And ethylene oxide is this molecule. I'll never ask you to name it. This is a molecule Dr. White worked with heavily in industry at two different companies. And it's a very interesting and useful molecule, very dangerous one too, but useful. All right, first reaction. If you take an alcohol, and I'm only going with alcohols, other functional groups react with ethylene oxide, but I'd cover that in a 2-semester course. And you react it with 1 molecule of ethylene oxide, you form this ether alcohol. And if you remember, and it won't be on the test, I talked about Deepwell Horizon oil spill and how I got involved with that to have the government stop them using a certain dispersant that was killing all the wildlife, which it did later on in the Gulf of Mexico by that oil spill. All right, now if you have N molecules or moles of ethylene oxide reacted with an alcohol, you get this polyether alcohol. Now, common mistake students make, they put the hydrox group inside the bracket. Nope, 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 it's wrong. Goes outside. And the number of repeating OCH2, CH2 is N, which comes from the coefficient, the number in front of the ethylene oxide. And if I were to ask you, give the organic product or products for the following reaction, what do? Well, you look for something different. What's not carbon? What's not hydrogen? Ooh, an oxygen with a hydrogen and a carbon. That's an alcohol. Ooh, 10 of something. And I'll just use the number letter N. And carbon, carbon, and oxygen, a three-member ring. That's ethylene oxide. And you get this polyether alcohol. Remember, OH goes outside. So this is my R group. This is N. So I can now write, that's my R group, bracket, O, CH2, CH2. What's N? 10. And I think if you go back and look at the video, one of the, not this molecule, but another polyethoxylated molecule, poly means many molecules of ethylene oxide, more than one is called many, is used as a spermicide. But you never thought I could get into some of the things I get into in this class. Just wait, there are more interesting things I'll get into later in the semester. All right. Next, I talked about aldehydes and ketones. You see the smile on my face? You know how people talk about comfort foods when they're not feeling good? If they eat something like potato chips or chocolate, it makes them feel better. Well, when Dr. White's not feeling good and needs something to pick me up, I think about aldehydes and ketones. They're my comfort molecules. All right, now you know I'm an organic chemist. Aldehyde, carbon, double bond to oxygen with a hydrogen on the carbon, double bond to oxygen, R group. This is called an aldehyde. Find the longest, and by the way, I'll teach you later on, I'll mention it in here. Carbon oxygen double bond is a carbonyl, and this is called the carbonyl carbon, which I'll never ask on a test, but I'll use now and other chapters. All right, how do you name it? Find the longest chain with the carbonyl carbon, the carbon double bond to oxygen. Name it as a alkane. Then drop the E and add Al. No number, because the carbonyl carbon is always one. You cannot have an aldehyde in a ring. It's impossible. So that's that. Now, for a ketone, you have a carbon double bond to oxygen with two R groups on there, and they can be the same or different. That's why I have R and R prime, just like in Matthews, X and Y. And how do you name ketones? Again, find the longest chain, name the longest chain or the ring that the carbonyl carbon is in as an alkane or cycloalkane. Drop the E and add ONE. For acyclic, you need a carbon, a number, which carbon is the carbonyl carbon, and that always gets priority, the lowest number. For cyclic, you need no number because the carbonyl carbon is always number one. They rock. And don't forget for ring to put the word cyclo. And if we look at this molecule, and if I were to ask you to give the IUPAC name, look for what's different. Ooh, an oxygen, double bond to carbon in a ring. This is a ketone. Why? Carbonyl. This R and R prime are connect together. And here's our carbonyl carbon. How many carbons in the ring? Count every bend in a line. 1, 2, 3, 4, 5. That's pentane. It's a ring. cyclopentane. It's a ketone, drop the E, add ONE, cyclopentanone. The carbonyl carbon is 1. Oh, we've got an ethyl group here. And you go clockwise or counterclockwise to give the alkyl groups the lowest number. Therefore, going clockwise, it's on carbon 3. So this is 3-ethyl. And I don't need a mile between the two words, even though if you put it on a test, I wouldn't mark it wrong unless they were on separate pages. That's better. 3-ethyl cyclopentanone. Now, there are 2 common names I asked you to learn. One, turns out the simplest aldehyde, R, can be a hydrogen. That's called formaldehyde. In my last patent, I used formaldehyde. Dr. White worked for a number of years for the largest producer of formaldehyde in the United States and not the world. And you should know, for common names, if I give you the name, you should be able to draw the structure. Formaldehyde. The simplest ketone is when R and R prime are methyls. Nobody calls that 2-propanone unless they tell you nobody calls it that, like I just did. It's called acetone. And you should remember acetone is nail polish remover, one of the 2 molecules that can be used for nail polish remover. Notice I didn't polish my nails tonight or yesterday either. All right, next, you should know, and when I write something red, that means it's really important. What is a carbonyl group? You should be able to draw it and describe it with words. Carbonyl group, carbon atom double bonded to an oxygen atom, is which I have here. And the lines could be R or H or whatever, but I just left them blank like that. You should know, what is a carbonyl group? By the way, Dr. White, if somebody ever asked me what kind of organic chemist you are, if I was being totally honest, I would only answer, I'm a carbonyl synthetic organic chemist, because most of, if not all, my work and somehow entire worked with carbonyl groups. All right. Now, how do you make ketones and aldehydes? Well, I've already shown you this. You take a primary alcohol and oxidize it, you get an aldehyde. If you take a secondary alcohol and oxidize it, that's what the O in the bracket means, you get a ketone. Now, a very special reaction is the Friedel-Crafts acylation. And that is where you take a benzene ring, and this is called an acid chloride, and you use aluminum trichloride catalyst. You form something very special, very rare, a carbon-carbon single bond, and you make this aromatic ketone. And as I mentioned, aromatic ketones play an important part, including sunscreen. Those are the molecules that absorb the harmful UV radiation to keep your skin safe so you don't get skin cancer. And let's take a look at this reaction. And if we look at that reaction, I'll do this one. We look for what's different. Well, we got a benzene ring right here. That's different. Don't forget in a benzene ring to draw the 3 double bonds or use the circle. And what do we have here? Carbon, R group, carbonyl, chlorine, and acid chloride. And we have this catalyst, aluminum trichloride. And this is Friedel-Crafts acylation. And you get this aromatic ketone. Remember, you don't break carbon-carbon single bonds, so whatever the R group will stay the R group. In this case, it's simple methyl. Therefore, I have my benzene ring, my carbonyl, carbon double bond to oxygen, and R is methyl. And you make this aromatic ketone. That was fun. Everybody got this copy down? Sam, did you get this copy down already? Okay. Now we go into the fun part, reactions of ketones and aldehydes. If you notice here, you have a carbonyl, R double prime, R prime, bracket H, close bracket. Now, this reaction occurs for both aldehydes and ketones. If R prime is H, it's an aldehyde. If R prime is carbons, it's a ketone. And you react it with an alcohol and acid catalyst. Remember, H plus is acid catalyst. Keep your eye on the carbonyl carbon right here. What's attached to it, R prime and R double prime is still attached to it. This opens up, you get a hydroxyl group on there and OR from the alcohol. Remember, you don't break carbon-carbon single bonds. Now, if you have a ketone, and sorry, sports fans, this should have this on here too. Don't forget to write this down because I forgot to right there. If you have a ketone or aldehyde and react it with 2 molecules of an alcohol and acid, you form an acetal or ketal. The carbonyl carbon, the R prime and or hydrogen, R double prime are still there, and you have 2 OR groups. Now, if these two reactions, didn't happen, we'll learn later in the semester, we wouldn't have any of the carbohydrates in our daily life. You know, all the good stuff like French fries, potato chips, pizza crust, bread, all those good things, noodles. Dr. White likes his carbs. Now, a special case, which I talked about, is in synthesis. We use this to put on what's called a protecting group. If you take a aldehyde or ketone, and this alcohol is called ethylene glycol. Notice there's 2 alcohol functions in the same molecule. The same reaction up here happens, except the bond between CH2 and CH2 is still there. I don't know why students forget to put that in there, but that bond is still there. And you form that acetal or ketal, and it's easily taken off. So it's like putting on a raincoat or using an umbrella when it rains. When it stops, you take it off. Well, this, you do that. There's some reactions when you don't want to react with the ketone or aldehyde, but other functions in the molecule, that's higher level organic chemistry, you need to protect the carbonyl. Fine. Now, once you get an acetal, if you react it with acid, catalyst, H plus, and water, you get back the aldehyde or ketone plus the alcohol you would have used to make that hemiacetal or hemiketal. Essentially, you're reversing this reaction up here, you're going backward. So, acetal, hemiacetal, hemiketal, R prime could be H or R. You get back the aldehyde or ketone plus the alcohol you would have used to make that. Now, this is one of the only 2 times I know of in all of organic chemistry where the carbon, you have a carbon with two single bonded oxygens to it. And in this case, one of the oxygens has a hydrogen. And you get back a ketone or aldehyde plus an alcohol. And the alcohol comes from the carbons on the oxygen. Now, the same thing reaction in terms of acid and water. If you take an acetal or ketal, and this is the only other case I know of in organic chemistry, where again, you have two single bonded oxygens to the same carbon, then you get back the ketone or aldehyde plus the alcohol you could have used to make that acetal or ketal. Now, notice I have the number 2 in quotes. Years ago, I had these twin sisters in my class, and if I didn't put that down there, they went ballistic. I mean, they really were upset when I didn't balance some general reactions like this. So I got in the habit of doing that. You don't have to on my test. And let's look at this reaction. If we take that molecule and react it with acid and water, what would be on a test? If you see this, that means there's two products you're getting. Sometimes I'll also put in question marks like this. Sometimes I won't put the question marks. But for this class as a gift, you'll see a plus sign that will tell you need two things. When I took organic chemistry, our instructor didn't give us that gift. Thank you, Dr. White. You're welcome. So if we look at this molecule, what's different? Ooh, two oxygens here to the same carbon. And you have carbons here and here. And each oxygen has carbons. So this ketal, R prime could have been hydrogen, but it's not. Acid and water. You get back the ketone or aldehyde you would have used to make that acetal or ketal, plus the alcohol. And to keep the twins happy, can I make a 2 any smaller? Yeah, maybe. All right. Now, here's the carbon, this carbon. And notice it's cyclic. I should have had that there. So these are connected together. Do you break carbon-carbon single bonds? No. And notice the carbon with the two oxygens becomes the carbonyl carbon here. So what does that mean? Yeah, the 6-membered ring with the methyl group. Here's that carbon I have in red, which will now be that product. What's our R? Methyl. Well, by the way, if it was more complex, the hydroxyl group goes on the carbon that the oxygen is bonded to in OR. In this case, only one carbon, so it's not that complex. And that's how you do it. All right, next couple of really fun reactions Dr. White loves, because it's one of my heroes in organic chemistry, Victor Grignard. And that's making the Grignard reagent and then reacting it. If you take an alkyl halide, react it with magnesium, you form the Grignard reagent. X can be chlorine, bromine, or iodine. And this reaction I did for my PhD thesis to help me make certain molecules I needed to make for my research. And the question is, what's the organic product or products that are following? Look for what's different. Ooh, what's not carbon, what's not hydrogen? An iodine and a carbon, that's an alkyl halide, or X can be chlorine, bromine, or iodine. Then we're reacting with magnesium, that's different. By the way, this is a really fun reaction to run. And you form the Grignard reagent. So do you break carbon-carbon single bonds? No. Here's my R group. So I have 4 carbons. The carbon with the halogen is the carbon the Grignard is bonded to. Remember, it's RMGX, not RXMG. The magnesium is bonded to carbon, and the halogen is bonded to the magnesium. And there's 4 bonds to carbon. And that's the Grignard you get. But that was fun. Now, once you make the Grignard reagent, it allows you to do something very special, very rare. Only a few reactions I know in organic chemistry allow you to do that, and that's make a carbon-carbon single bond. And if you start with a ketone or aldehyde, react it with a Grignard, first step, second step, acid and water, you'll form an alcohol. And you formed right here a carbon-carbon single bond. And this is a way of making more complex molecules. For some reason, students have trouble with this, so I better do an example. So if we look at this molecule first here, what's different, what's not carbon, what's not, ooh, an oxygen double bond to carbon with carbons here and carbons there. That's a ketone, a cyclic ketone. So I can do this. This so happens R and R prime are connected together in a ring, but this could have been an aldehyde too, but it's not. Then we have a 2-step, and right here, what's different? Carbon, 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 carbon. Ooh, magnesium bromide. That's a Grignard reagent. Remember, X can be chlorine. In our case, it's bromine or iodine. Second step, acid and water. What happens is the Grignard attacks the carbonyl carbon, opens it up, and the acid turns it into an alcohol. And what you get was attached to the carbonyl carbon, R prime or H, and our double prime are still there. This opens up to an alcohol, and you make that something special, something rare, carbon-carbon single bond. So if we have our carbonyl carbon, what's the, oops. Every once in a while, it doesn't want to go over back to the black pen. We have our R group attached to this carbon. which is this carbon right here. Now, we'll have a hydroxyl group. And what's our R triple prime? This N-propyl. The carbon with the magnesium bromide is the carbon that bonds to what was the carbonyl carbon. The carbon with the magnesium halide is the carbon that bonds to what was the carbonyl carbon. And that's the N carbon of 3 carbons. And that's how you have fun with a Grignard. All right, next reaction. Remember, a carbonyl is a double bond between oxygen, hydrogen, oxygen, carbon, and it's a pi bond and a sigma bond, just like a carbon-carbon double bond. So if I add hydrogen and catalyst can be nickel, platinum, or palladium, I break the pi bond, and now each atom of that carbon-oxygen double bond gets a hydrogen. And this is a way of making alcohol from a ketone or aldehyde. And you can get ketones and aldehydes in many places in nature. Now, because this could also react with a carbon-carbon double bond if you didn't want to, the great organic chemist H.C. Brown from Purdue came up with this reaction. If you react the aldehyde or ketone with LiAlH4, called lithium aluminum hydride, second step, acid and water, you do the same thing. You break the pi bond of the carbon-oxygen double bond, and each atom gets a hydrogen. Now, the nice thing about lithium aluminum hydride, LiAlH4, this will only react with carbonyl groups. It won't touch a carbon-carbon double bond. So if you have both your molecule and you only want to do the carbonyl, use lithium aluminum hydride. I did a lot in grad school. And the final reaction is the aldol condensation. And my gift to you is if you see two of the same aldehyde reacting with base, and I'll only use sodium hydroxide and water. Once in a while, I'll forget to put the water down. If you see that, email me and I'll send out an email to everybody I forgot to, but I don't think I will. I hope I don't. And remember, the carbon bonded to the carbonyl carbon, called the alpha carbon, has acidic protons, and the base takes that off to form an enolate anion, negative charge on that alpha carbon, and that attacks the carbonyl of the other carbon, and it opens up. And this is another reaction where you form carbon-carbon single bond, and you form this aldol condensation. And here is the new bond we formed. And Dr. White loves enolate anions because my PhD thesis dealt with a very specialized enolate anion, not with this reaction, another reaction which I don't teach in this class called the Michael reaction. Now, as a special 4th of July coming up treat to all of you, let's play that fun game, circle and name the functional group, 2 points each. And how do you play that fun game? Circle and name the functional group, 2 points each. Aren't I a nice guy letting you play this fun game? Don't answer that. And there you go, A and B. Your turn. I'm going to let you have some fun right before the 4th of July. Circle and name the functional group or groups in the following molecule. You don't have to name the IUPAC name of the molecule. Just circle and name the functional groups, 2 points each. And when you're done, give me a thumbs up. When you're done, give me a thumbs up. All right, everybody's done. My turn to have some fun. How do you play the game? Circle and name the functional group, 2 points each. You look for what's different, what's not carbon, what's not hydrogen. Should get your attention like that. For this test, look for oxygens. Ooh, A, oxygen, hydrogen, and a carbon. You don't have to do this, but I will. Alcohol, but you have to write down alcohol. Am I done? No, there's another oxygen right here. And here we have, and you don't have to do this, but I will, carbonyl, carbon double bond oxygen, hydrogen R group, and that's an aldehyde. Now, let's go to B. Ooh, there's an oxygen here on a carbon. And that's this. You don't have to write the ROH, but circle and name it. That's an alcohol. Are we done? No, here's another oxygen right up here. And this one, we have carbonyl, carbon, carbon, and it just have to be connected together. We have a cyclic ketone, and you just have to write down ketone. Oh, by the way, ketone is not spelled with a Y in there, even though students do that. I don't take off points for wrong spelling. Dr. White was always the first one down to spelling bee. Shh. Why are we done? No, there's another option right here. We have carbon, oxygen, carbons, and that's an ether. Are we done? No, I threw everything in but the kitchen sink. We have another oxygen right here. And here we have our group, carbonyl, hydrogen, and that's an aldehyde. And that's how you play that fun game, circle and name the functional group, 2 points each. In reality, this is very important because if you can't name a functional group in a molecule, you're not going to be able to name it. If you can't identify the functional group you're dealing with in a molecule, you won't understand what reaction it will undergo. So it's important to know how to identify and name functional groups. With that, I'm done. I'll stick around if anybody has any last minute questions. Remember, tomorrow morning, the 3rd of July, I will be giving test number 2. I'll be sending out the password. Remember, you'll have until Friday because Thursday, 4th of July, is a holiday. So my neighbors, I have some neighbors next block over, they're in competition who can set off the most fireworks and spend the most money on it. They put on a good show, each of them. Boy, it's been going on for years. And also where I live, I can watch from my front lawn my village's fireworks, which is nice. My neighbors do that too. We're out there with a drink or 2 or 3 or 4. Anyways, with that, I'd like to wish all of you a happy 4th of July. And don't forget, study. Don't forget, keep on handing in the labs. And with that, I'm going to say Gang Gesund, which by now you know means go in health in Yiddish. By the way, COVID is still out there. My best friend, luckily because he's been vaccinated, he went, it was about 3 weeks ago, he went to, with his wife to Seattle for a wedding. And he had stopped wearing his mask. And I don't know if it make a difference or not. I think it might have. He came down with COVID. Luckily, it wasn't that bad, even though it wasn't that fun. He was sick for about a week and a half with a real bad cold and week, but he's better now. With that, I'll say Gang Gesund. Goodbye. So that from Granny to Beverly Hillbillies. Bye now.